Our next presenter is Andrew Yip from the Immersive Design Lab at UNSW. He's a designer and art historian who researches applications for digital technologies and their abilities to present and interpret cultural heritage sites. And he's going to be presenting some of his work from the GLATS project in Serbia. His paper is the cross-platform palimpsest, archaeological visualization and gamification for the public engagement and site analysis of a late Roman palace in Serbia. So thank you, Andrew.
Thanks a lot, Michael, and thanks for having me, everyone. I just firstly want to acknowledge that I'm coming from Darug and Gundungurra land in the Blue Mountains, just west of Sydney. Embarrassingly, I noticed that my paper title is actually the most pretentious and longest out of everyone's, just trying to sound serious, but it can be summarized really simply. And I think it follows on really, really well from many of the ideas that Eric and Alberto raised this morning already. Firstly, this idea of how do we avoid the kind of heat death of application, sustainability and data sustainability. How do we compile all of our massive data sets of different, data types and functions into a platform that can serve multiple purposes? And particularly, I'm really, really interested in particular with this project, how we can use data and interactive platforms to serve not just academic and research methods, but how we can extend these experiences into museums, into communities, to develop communities of practice and wider social impacts around from the same data set. So Michael, summed up what I do. I basically work with GLAMs to produce interactive, immersive exhibitions. I'm not an archaeologist, so you'll have to forgive me if I mislabel any archaeological terms, but I've worked on many site visualization projects in various capacities. My background is in art history and also museums, and I think I suppose my mission statement is that I'm really, really interested in breaking down some of these traditional museological silos that emerge in GLAM practice, where the digital is still referred to as the digital instead of an investigative methodology that's part of the core function of GLAMs. And I really like to work cross-disciplinarily, work across barriers, and work in a kind of co-design sense so that we can, benefit from having more disciplines in a particular visualization workflow. And my particular bugbear is that I really believe that the use of immersive and digital technologies in museums should always be human-centered and should lead from a position of human-centered and user experience design. Picking up on what Eric was talking about before, I think the worst possible aspect of trying to employ digital technologies in the cultural sector is to lead platform first, because then we're designing shoehorns rather than designing human experiences. So I always lead from the human first. So what I want to talk about today is these four major components coming out of the GLATS project. This idea of the compilation of site data from a traditional GIS platform into an interactive real-time simulation engine, and the cross-platform functionality that we gain from compiling things in a game engine. So we are currently in the process of outputting the same data set to a 360-degree cinema, VR headset, PC-based application, and also augmented reality. How we use this for training and capacity building in local museums and professionals, and how the core function, as I was just talking about, is this idea of public engagement through education programs. I'll just quickly, so Michael, how long does my time allotment run to?
We've got about 15 minutes, but that includes question time.
Okay. But I just wanted to quickly run through just a couple of my previous projects so we can get an understanding of where we're going with the GLATS project. This is a very, very human-centered experience, this idea of bringing hidden histories to life, the affect-based museology that I opened at South Australian Maritime Museum in January, called Windjammers. And we engineered this big translucent immersive screen and a motion detection system where there's this living world, and the behavior of the participants in the physical space has a subtle but cumulative effect on the environment. So we engineered this environmental systems like water. The waves change from calm to storms based on the behavior of the participants and the narrative itself. It's an immersive exhibition based on diary accounts of sailors going from Adelaide to England. But it becomes this participatory journey because the user in the museum space gets a subtle sense of the world responding to them. So I'm really interested in living world dynamics and embodied control systems that don't require, onboarding and stuff. This is a work I had at SIGGRAPH Asia a few years ago, where I made an emotional map of a First World War battle, Villa Bretonneux, and you could wander around in the 360-degree cinema, encountering algorithmic transformations that describe the sentiment analysis of the history of that particular battle. So again, this like affect-based exploration of historical space. This is an exhibition I built for Powerhouse Museum for the 50th anniversary of the moon landing, where we built a kind of interactive journey of Michael Collins's experience with records from NASA and the Smithsonian Institution. And it was all gaze-based, so that we were trying to build this accessible platform for understanding narrative and historical contexts. And this one is showing currently at Heide Museum of Modern Art at the moment, which was an extended project in digital conservation, reconstruction, and simulation, where I simulated and reconstructed two really important kinetic aquatic works by Marjol Hinder, the mid-century Australian sculptor. And this particular work is actually at Macquarie University. It was in the sculpture garden, but now is just sort of sitting around. So we use 3D scanning, animation, water dynamics, all this kind of stuff to simulate the original architectural context of the work itself. So those are the kind of, and I'm also interested in like speculative object reconstruction as well. So those are the kinds of ideas I'm interested in, but always, that human side. Now, Project GLATS is a really, really big multi-year project that we began in 2017. And the site is about 4 kilometers southeast of the modern town of Sremska Mitrovica in Serbia, which stands on the foundations of the old Roman capital of Sirmium. And it's a really important site because there were actually 18 Roman emperors who came from Serbia and 11 from this particular region. And the site that we're working on was identified in the 19th century on the grounds of a farmer. And we have early records of from a local teacher called Ignat Jung, who discovered traces of a large Roman villa here, including a massive mosaic, and he found porphyry and all this kind of stuff. It's speculated that this might be the palace of an emperor called Maximian Herculius, who is recorded in the epitome of the De Caesaribus, I think it's pronounced, that he built a palace on the farmlands that his parents worked as peasants. And further evidence for this came from World War I, when the site was a battlefield. And the Austrian army occupied this site and dug headquarters trenches through the site itself in which they discovered large mosaics, the marble head of Venus, and other evidence that this was a significant site. This is geophysics from 2014, when the project started to become more of a reality, and it shows a really extensive structure, many structures. In fact, it extends a similar distance into the forest in the southwest as well. But we began work in earnest on the site in 2017, and it's being led by the University of Sydney by Professor Richard Miles, in tandem with the Belgrade Institute for Archaeology, Dr. Stefan Poplazic. This is the site there, you can see Richard. So this is 2017, I think. This is early preservation of this mosaic that we uncovered that we think is 600 square meters in size, which is extraordinary. Just another early context. That's me setting up a drone. Now, since breaking ground, we've had a top-to-tail digital workflow, and this is where we sort of get into the terrain that Alberto was talking about. You know, one of the early concerns was, how do we take all the data being gathered and use it for multiple purposes and compile it? So basically, my job on site is to run a 3D lab that we set up every year that includes, you know, all the usual things: digital photography, photogrammetric scanning, aerial imaging. We also have LiDAR from fixed-wing aircraft. We have ground-penetrating radar. We have ground-based photogrammetry of all of the trenches. We have a filmmaker, Chris Davies, who's a big VFX person who shoots hundreds of hours of film that we are producing into an ongoing docuseries. And so the digital capture is integrated at every level. So basically, after you know, a find is recorded, it goes to the finds room for triage and washing and conservation or whatever, and it comes to my lab. It's documented, scaled, all this kind of stuff, and then we compile all of the technical data into ArcGIS, but also into a data server that we have. And then from that, I compile everything in Unity, which then can be tailored to output interactive platforms for the AV immersive cinema at UNSW, a PC application, and AR, all of which I'll show you in a second. And obviously the data serves the website and this docuseries. So from the ground up, we're always thinking of ways in which we can make the best use of, you know, these like terabytes and terabytes of data that we're gathering, you know, for multiple applications. So if anyone wants to have a look at them, it's a very charming and funny documentary about season 2. We haven't dug since 2019, unfortunately. So there's just only one season of dig life, but it's a fun watch. So I'll just show you some of the data we capture, obviously through, you know, all the normal methods, photogrammetry. So this is like a torso of what might be an Athena Parthenos that we collected in 2019. There's a marble hand, maybe of like a Doryphorus, maybe, or something. It's got like a trunk for a spear, or I don't know. We dug up this intact votive pot with fish bones inside, and we obviously capture the trenches at key points in their excavation. So this is a major site, a major trench in the site where this the semicircular little structure here actually is lined in places with in situ green porphyry.
Sorry, Andrew. Got 5 minutes if you want to keep going, but we might lose question time.
Oh, sorry.
No, it's all right.
Aerial photogrammetry from the drone. Now, this is what you're looking at now is a screenshot from the real-time application that I've built and I'm working on. So it's basically a holistic mapper that runs in real time in Unity. You can correlate all the data maps. So this is the glowing thing you see is a model I've made of the ground penetrating radar. And so that can be switched on and off. We can switch on and off correlations with GPS data with the 19th century maps. We have the 20th century Austrian World War I maps, and they all correlate pretty well. We've got real-time GPS location, so you can mouse over. You can measure across the, you can measure from one point on the ground to another, and it gives you a very accurate measurement. You can change the position of the sun so that we can actually use, because you see the ground the ground deviations I made straight from the LiDAR. So just by rotating the sun, you can correlate otherwise hidden, road structures with the maps and all this kind of stuff. And you can actually transition down in real time to one-to-one view, one-to-one scale, and walk around in virtual reality. So this is the same section, but you just go down. And so this is what it looks like. Now, within this is an embedded archive. So this is the gamified element in which it's trying to go for this non-linear narrative mode where you can walk around the site and then essentially pull things out of the ground. So there are different levels of embedded archive. So if you go to this trench in the top left here, there's a hotspot that appears on the map and in first person mode. And then you can bring up that trench itself. And then embedded in that trench are the locations of the objects that were found in it, which you can see on the right-hand side underneath my little tab. You can then bring up the next level of model, which is the embedded 3D model from the photogrammetry lab that we obviously post-process. And you can see a couple of tools on the left. We can do surface measurement. We can do volumetric measurement in real time. And that little lamp, so you can pull the sun around and inspect the object. This isn't porphyry, that's a mistake. But we've got, each of these things is constructed as what's called a scriptable object. So we tie all its metadata to it, and it appears automatically as you pull it up in context. This is an AR table that I made in 2019 on site. So it's a plaster architectural model of 17 cross sections from the geospatial data. And then we projection mapped the aerial data onto it, and then correlated the ground penetrating radar data so that when you looked over it with the iPhone, you could see the GPR data coming up out of the map. And we use that for public engagement. So here, we have an annual open day where we bus in hundreds of people from the local community to take tours and learn about the site. And this is me talking to the mayor and local politicians about visualizing the site and how to explain, the significance of the GPR data to them using this augmented reality table that we constructed. So again, big focus on public engagement. And we run a 2-week education program where, again, we try to tie these digital workflows into the public education program. It's led by Dr. Alan Dern, who's a Roman historian. He's at Sydney Grammar. And he teaches them mapping. He teaches them like mapping, archaeological drawing. And then I teach them 3D scanning and game design. So they come to me for a couple of days and we do photogrammetry workshops. Here you see us working inside the Sremska Mitrovica Archaeological Museum. So what I'm trying to do is capacity build so that the students can actually help the museum to document their collection. They have no collection website, no database, no public database. They can't even exhibit the key objects from the collection because they were looted in the 90s and they don't have proper security. So what every year I spend a week or so at the museum documenting, like trying to get as much done as I can. But I'm building we're trying to build a skill set within the community of like community archaeologists where they can actually assist the museum in documenting it. So from the 2-day photogrammetry workshop that we did, these are actual student models from high school students, which is wonderful. And then the long-term plan is we've designed, the idea is there's this big farmhouse that we're trying to get the mayor to allow us to build an on-site visitor center in. And key to this will be the digital exhibition stuff. So we've designed early plans for a range of digital interactives using 3D printed objects and the platforms that I've shown you. But this is, that's all very far in the distance. So we haven't been there.
Sorry, Andrew, we're going to just have to conclude
sorry.
here. So
yeah, sorry, I'll stop there. Sorry, I had to.
If you want to make a quick conclusion, that's
look, basically the conclusion I want to end on is that we're trying to work on models for making the best use of the data for as a wider range of audiences as possible, and making and focusing on affective experiences rather than simple, cold analytical methods. So that's pretty much it. I yada it, but hopefully you get the idea of the scope of the project.
No, thank you. That's it's really interesting, and I was meant to be there in 2019, so it's nice to see what I missed, which demonstrates the utility of all of this.